video, I will show you an investigation of sugar dissolving in water at different temperatures, and how to use a digital animation and our knowledge of how atoms and molecules move to explain why this occurs. Start by posing the question to students. How does the temperature of water affect how quickly sugar dissolves? This activity is an excellent opportunity to introduce principles of scientific investigations, such as how to ensure a fair trial by only changing one variable at a time. Students may use their investigation planning sheet to help with the planning. Each group will need some sugar and a teaspoon to measure, or 3 pre-measured sachets of sugar, as well as 3 clear cups, 3 stopwatches, and a thermometer. Each student will also need something to stir with. Students then fill each cup to the same level with cold water, room temperature water, and warm temperature. You want about 50 degrees, or what you might get from a hot water tap. Have each group measure the temperature of each of their cups of water and record it. Each student should then place 1 level teaspoon of sugar in their cup and begin their stopwatch while slowly stirring. It is important that each student stirs at roughly the same pace. Roughly 1 rotation per second is a good speed. Students should continue stirring and record how long it takes until the sugar crystals are no longer visible in their cup. Once students have packed their equipment away, facilitate a teacher-led discussion. Ask students how the water molecules in liquid water move. Point out their particular bent Mickey Mouse shape, that they are close together, that they mingle randomly, and that the hotter they get, the faster they mingle. This animation shows how the bent water molecules in liquid water are in constant random motion around a sugar molecule. The electrical forces between the bent water molecules and the larger sugar molecules carry the sugar molecules around inside the liquid. But note that sugar molecules are not actually bowl-shaped, but quite a complicated shape in reality. This investigation will help students understand how the more rapidly jiggling water molecules in warm water interact more frequently with the sugar molecules, and so break sugar molecules off a sugar crystal more quickly and more easily, causing the sugar to dissolve faster than it does in the cold water, where the water molecules are moving more slowly. The digital animation shows how the electrical forces between the bent water molecules and the larger sugar molecules carry the sugar molecules around inside the liquid. When the larger sugar crystals are broken up by the colliding water molecules, they seem to disappear, and the water and sugar mixture goes clear. At the end of this activity, ask students what would happen if the sugar solution were left in a warm place and the water molecules evaporated into the air.